Number three, the ratio test. Looking at that, it has this form here and these conditions, and use that to determine whether this converges. So that ratio test is typically used when a sub n contains factorials or constants raised to the nth power. So this one has both of those. So for a sub n plus 1, what we want to do is just replace n with n plus 1 everywhere and evaluate the limit. So we'd have a 2 to the n plus 1 over n plus 1 factorial over 2 to the n over n factorial. And we can rearrange that and simplify, and we'd end up with this, just moving, basically inverting and multiplying that denominator. So we end up with that form. And just being careful with our algebra here, just moving now the 2 to the n on the bottom, this one, move that up and make it a 2 to the minus n, and similar bases multiply together, we can add the exponents. So look how the n's add up to 0 there, they're equal and opposite, so we just have 2 to the 1 is 2 on top. And then if we have n factorial over n plus 1 factorial, then that's just equal to n plus 1, right? Because we're going to, let's say n was 6. We'd have 6 factorial over 7 factorial, which is like 7 times 6 factorial. And so the 6 factorials cancel, we're left with 7. We're left with n plus 1. So hopefully that makes sense. Take the limit of that as n approaches infinity, you'd end up with 2 over infinity, which is 0. And so since L is less than 1, our limit is less than 1, we'd say that series is absolutely convergent.